Here's one for you to try. We are given the position of some object, s of t equals 11t cubed plus t plus 1, and the goal here is to find the instantaneous velocity, which we'll call ds dt, and then evaluate that instantaneous velocity function at t equals 1 second. And in this example, we're using the limit definition of the derivative, so I'll bring that up. Recall that is f prime of x, or t in our case, equals the limit as h goes 0 of f of x plus h minus f of x all over h. And again, those x's can be replaced with t's with no loss of generality. Okay, so pause the video, try this on your own, see if you can evaluate that derivative. Okay, let's do it together. We have the limit as h goes to 0 of, this will be s of t plus h, so 11t plus h cubed plus t plus h plus 1. Okay, minus, and then I subtract off the entirety of f of x. So this is going to be minus, and then we just essentially copy and paste f of x right back into there. Okay, so we're subtracting off 11t cubed plus t minus 1 all over h. This first bit here is our f of x plus h, or let's make this s of t plus h, keep our variables straight. And this second bit here is s of t. All right. Make sure that you included the plus h inside the parentheses. That's one of the biggest mistakes with these, is that plus h somehow gets outside of the parentheses, and then you are doomed. The most challenging part here is the algebra. In fact, the most challenging part of all of calculus is seemingly always the algebra. But we have to expand this thing, t plus h cubed. In order to do that, I recommend just essentially memorizing. You don't have to, but it really saves you a lot of time memorizing the binomial cubed equation. Essentially, the coefficients are 1, 3, 3, 1. It's not that hard to memorize, and it saves you a lot of time. So we have 1, so a cubed, 3 plus 3, the a's go down 1, the b's go up 1, plus 3 again, a's go down 1, b's go up 1, so 3a squared b plus 3ab squared, plus, and then we're back to 1 again, and then we're all b cubed. That's the most direct way to deal with a plus b cubed. You're more than welcome to peel off, a single a plus b, and then do a plus b squared and expand that out. What you absolutely can't do, so I'm writing no here, is this: a plus b cubed equals a cubed plus b cubed. No, can't do it because there's a plus in there. So make sure you watch out for that kind of thing. Okay, so moving on with this example, we now have the limit as h goes to 0 of 11, now I'm doing that expansion, t cubed plus 3t squared h, t's are going down, h's are going up, plus 3th squared plus, now we're at all h cubed, plus t plus h plus 1 minus 11t cubed minus t and minus 1. Whew, all over h. We get some nice cancellation here. Let's see here. We have this 11t cubed, so I'm just going to cancel the t cubed because it's multiplied by 11, and we have minus 11t cubed here. We have plus t, plus 1, minus 1. So cleaning this up, let's see what we're working with here. Limit as h goes to 0, we have, I'm going to multiply this 11 through, so 33t squared h plus 33th squared plus h cubed plus h, there's still this h hanging out here, all over h, and now finally we can cancel that h in the denominator. Right, so we have this h canceling here, here this makes this 1, here this makes this h2, and this entire h cancels, leaving us with just a constant of 1. Okay, so now we're ready to evaluate this limit. Let's clean it up one more time and then we'll evaluate it. The limit as h goes to 0, 33t squared plus 33th plus h squared plus 1. And now we can easily evaluate the limit. This is just a polynomial. We can just plug in the limits and plug in, h is approaching 0, so we essentially plug in 0 for h because it's a polynomial, which means that these terms with an h both go to 0, leaving us with our answer, 33t squared plus 1. There is the derivative, or I guess in our case, this is the velocity ds dt, given that position function. So what does this tell us? This tells us the velocity at any time, right? So if we want to know the velocity after 1 second, we can do that. If we want to know the velocity after 2 seconds, we can do that. The example specifically asks us, so let's do part B here, to find ds dt at t equals 1 second. Okay, so now we're just doing essentially s prime of 1, which means we're plugging 1 in here. So 33 times 1 plus 1, so 34. And then we'd expect to see some kind of units here. I don't think this problem had units, but it might be something like meters per second, just to make it, consistent with what we'd expect to see in velocity.